Arrays and data structures in Python. We discuss about Numpy arrays, some special arrays. Import Numpy as NP. Then if you use I is a name of the function. I is identity. And inside that you write 3, you will have a identity matrix. If you think this is a matrix 2 by 2, this is a two-dimensional array, and it has 1, 2, 3 rows and 3 columns. So if you write 3, so it will be an it is a square matrix. Okay, and if you write np dot zeros in bracket, you write 3, it will of course create a one-dimensional array where all the 3 elements, because 3 are for the 3 elements, here 3 are for the orders, 3 by 3. Okay, so it will create 3 zeros. It is in terms of if you write np dot zeros, inside that if you write a tuple 3 comma 3, it is a tuple, then of course you will have a 3 by 3 matrix, because we have written it here 3 by 3. This is the shape of the array, so you have a 3 by 3. This is, you can think of a null matrix. This is an identity matrix, this is a null matrix. So often you use these things in your calculations, in your algebra, in your some other parts. So if you write np dot full and you write 3 comma 3 is a tuple, and so the shape of the array will be 3 by 3, and you write comma 5, that means the matrix will be a full matrix, that means all the elements will be with 5. So here are some special kinds of arrays which you may often need in your mathematical calculations, in physics, in data science, in elsewhere in statistics calculations, and other things. Okay, so suppose you have an array A 1 2 3 4 2D array. There is a function called zeros underscore like. So what does it do? If you write A here and the array A you write inside this as an argument, you will have a zeros like. That means this array is 1 2 3 4. This is also, that means it's a 2 by 2 array. This array will also be 2 by 2, but the elements will be replaced by zeros. So it will create a equal, the same ordered matrix, but with all the elements 0. If you write if you use diag is, inside you write 1 2 3 is a tuple, diag is diagonal. So you have an array 2 by 2 array, the 3 by 3 array, and the diagonal elements are 1 2 3. You have not mentioned here the order, but automatically, since the diagonal is 1 2 3, that means 3 diagonal elements, that means it will be a square matrix of which has diagonal 3 elements. That means it will be 3 by 3 matrix automatically. Okay, so that way you create a diagonal matrix. If you write np.diag 1 2 3, now you write with some keyword argument k, say k equal to 1. That means you have created a matrix where the off diagonal element, the first off diagonal element, this is the diagonal 0 0 0 0, and the k equal to positive 1, that means it will be the first off diagonal element on the upper side will be 1 2 3. Again, you have not mentioned here the size of the matrix. Automatically it is implied that the 1 2 3 it will fit here only, so the diagonal size will be 4, more than 1, more than this, and so the matrix will be 4 by 4 automatically. So this is the off diagonal matrix with off diagonal elements you have created. So this way you can vary. K equal to 2 means you will see here the elements will be created. K equal to -1 means the elements will be created in the first off diagonal, but on the lower side, and so on. So in this way you can create very many different kinds of 2D arrays, which you can treat them as a matrix, and which you can calculate, we can use in your calculations. Inner product is defined in a way. Suppose you have a two arrays u and v, you can consider them as vectors. In your linear algebra class or in your vector calculus class, you have vector algebra, you have known how to take inner product or dot product. So the inner product is more general. So if you write these two vectors, first components 1, second component wise 1, 2, 3, and the components are minus 1, 0, 1. So if you write np dot inner, and inside that you write u comma v, that means it will actually, what it will do, it will actually take the products of the corresponding elements. That means 1 into minus 1, 2 plus 2 into 0, plus 3 into 1, you check, it will be 2. If you write np dot inner, the same function inner, and you write u comma 2, of course it will be the vector will be multiplied by 2. That means each of the elements will be multiplied by 2. Okay, 2, 4, 6. If you write np dot inner and say you write np dot I means, and bracket you write 3, I means I means identity matrix of order 3. So now you take multiply with, I mean you take the inner product with 5. 5 is the scalar. So what it will do, it will actually multiply all the elements with 5. So 5, 5, 5, and all the elements are 0. So this way you can manipulate, you can create very many different kinds of arrays and matrices. So suppose you have now you have instead of vector, you have a two-dimensional array. I mean it's a 2D array, and it's another array, 2D array. You can think them as matrices. And you now write np dot inner a comma b. What does it mean? So that means the inner product of two matrices. So the rule of the inner product, you extend this in 2 dimensions. That means what it will do, it will actually take product of row is to row. This row will be multiplied with this row. That means it will be a vector. It will be a vector. So 1 into 1 plus 2 into 0 plus 3 into 1, it will give you 4. Then this first row and the second row of here, and it will give here and so on. So this is the inner product between two matrices. Of course, this is not the matrix product. So it is a row versus row product. So matrix like operations. Now you can treat the arrays as matrices. So what is the difference between 2D array and matrix? The difference is the only one place, that matrix product is something different. You know, you have to take product with the rows with columns, okay, of the next matrix. So suppose you have A is a kind of matrix, you can treat 1, 2, 3, 4, 5, 6, and B you have another matrix. This is 2 by 3 matrix, and this is 3 by 2 matrix. So you can take the product of A and B. So now the matrix product is actually done by this dot dot function. So if you write np dot and inside that you write a comma b, that means it will take a matrix product of A and B. So what it will do, if you write if you place the two matrices side by side, A matrix, and then you take the B matrix, put it here, and you go over these rows and go over these columns. So 1 into 1 plus 2 into 3 plus 3 into 5, it will be 22, and so on. So this is the real matrix product, and you do this with dot function. So you can also write A dot, inside you could write B. So it is the same. But if you write B dot A, that means it is the product of BA, matrix BA. So of course it will be something different. You do it yourself and you see, following the same rule, you see this is now a 3 by 3 matrix. So of course then A dot B and B dot A are not the same thing. This happens because in the matrix product they don't commute. AB not equal to BA in general. So now the real matrix. So you have actually matrix function. So from Numpy you call this matrix, and suppose A was this array. So A was this array, and now you put this A inside this matrix function. That means A has become, but this thing has become a real matrix in terms of the matrix product. So rename it say as X. You could name it anything, and now you the same the other array B, you convert it as a matrix and say rename it as Y, say for example. Now the matrix product is simple. You don't have to write dot or something. You just write a scalar multiplication. You write X star Y, you get the same thing. You write Y star X, you get this product of B and A matrix. So this is simple. If you convert it in terms of matrix, you get the you get to do in an easier way. Complex matrix. I told you the complex arrays in some other episode. Now C is the complex matrix. All the elements are complex. So if you now write C dot T, you know T for capital T is for transpose. So matrix will be transposed. That is nothing new. But if you write C dot conjugate, so the elements will be conjugate of these things. That means elements will be 1 minus 0 minus and so on. But you know C dot H means you have used in physics and in mathematics that the conjugate, if take conjugate and transpose both together, conjugate transpose, this thing is called adjoint. So it is often written as C and the top of it you write a dagger. So here you write C dot H. So you write you get a adjoint matrix. So adjoint matrix is nothing but conjugate transpose. You see that if you transpose this and then you this matrix of this matrix, not the C matrix, you take the conjugate of this, you will get this thing. See, C dot T, conjugate is 1 minus 2, then it is 2 minus 3, it is 2 plus 3 and so on. So in this way you can create very many different kinds of matrices. For complex number, you create this adjoint matrix, which you can use in your linear algebra applications. Well, now something else. So suppose with the help of Numpy methods or functions, you can actually incorporate data from outside, or you can store data in a file which you save in some other place. So here in this little demonstration, I'll show you how you can import data files, text files. This is TSV is text. This is the text separated value. This is tab separated value, tab space separated value, tab separated value, and CSV is comma separated values. So in the files. So suppose the file name is test.dat, okay, and the file looks this. This is a TSV file, or sometimes you can also call it CSV file. So it's a text, simple data file, simple text file. So you have these columns and you have these rows, this row, this row, this row, and these things. You have to deal with this data. How to do that? This data, unless you convert in Numpy array or in some list, you cannot proceed with these things, because once you convert these things, this entire tabular form data into the form of Numpy array, then you know how to slice the data, how to index, reindex, how to manipulate, how to take products of these and that and so on. And then you can of course go on doing your physics calculations, your science calculations, or in big data analysis, whatever. So this is very important for you. Okay, so next, so there is a function called load text. So you give the file name here. Of course, if your file is somewhere else, not in your Python directory, you could give it some the path name. If you could put the path name before that. So anyway, this file name is test.dat, say data file. So you load this data file, and this you now rename it is at say something. I call it say data. And this, if you now type data, so data will be what it will be. It will be a Numpy array. See, you have two these things, two square brackets here and two square brackets here ends. That means from seeing it, you can understand this is a 2D array, 2D Numpy array. So that's it. If you have a 2D Numpy array, you can now slice it, you can now find the indices, you can find the data, you can extract them out, you can do anything. Okay. Also, you could use gen from text. There is another method. It's called gen from text. The result will be the same. Now the opposite. You have this data set. For example, your data is like a Numpy array. You are doing some Python, writing some Python program. You have written some program or script where from you have generated this data in the form of Python a Numpy array, 2D Numpy array. Now you want to store this data in a file from here. So you can write np.savetxt. So the file name is say I call it say random.dat, comma, with inverted comma, of course you have to write, as it is a string, then comma, you write this data. Data is a Numpy array. So if you do this and you now check how it looks in the file, it will remove these brackets and everything, commas and everything. It will write in this tabular form. So that is this. The last thing is mesh grid. You need it to create contour plot and 3D plot when you will use another package matplotlib to create beautiful pictures. So Numpy, import Numpy as np, and to plot you use this matplotlib.pyplot as plt. This you don't have to remember now. When you will see encounter this again. When you will plot, you will encounter them again. So pyplot is a module in matplotlib package which plots 2D data. I mean in a two-dimensional plot. So this is say x array, and y array is also the same, x and y. And now I want to create a grid out of this. So the mesh grid, that means I want to create a network, I mean the square lattice kind of thing, where each point will be x, y, corresponding x, corresponding y. Here x and y are the two same arrays, just for demonstration. So you call it capital X, comma capital Y equal to np dot mesh grid x, comma y. You can give any name. So another now to have a three-dimensional these things, at each point xy you have a value. The value is z. It can be for contour plot or it can be for 3D plot. Okay. Now you write this as, say, for example, some function. Say np.sign, in bracket you write capital X that you have created. Capital X, capital Y means these things, these mesh grid points. So x say square plus y square. And now you plot through contour f. This is a function which will plot your continuous contour plot. So contour f function, and you inside that you write capital X, capital Y, capital Z. Now, and on the interpreter you have to type this plt.show and see this is the plot you got. So this is the end of the